Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 59, we will talk about fire stations and fire services. So, the different concepts that we will cover are on fire services in India, fire station requirements, emergency fire service design, location allocation of fire services, then we will talk about the allocation models, and finally, we will do a case study on Tehran. So, fire services in India were initially started in Bombay and Calcutta, and usually it was first the services were provided by the police department, but eventually it was taken up by the municipal corporation, and in 1872 the Calcutta Fire Brigade was formed by the Calcutta Municipal Corporation. So, after that, during 1950s, in the meantime, there was a Standing Fire Advisory Committee was formed, SFAC, during the year 1956 under the Ministry of Home Affairs. This committee explored the different technical problems which was there in regards to fighting fire, what sort of equipments were required, and all these things were explored. And finally, this committee led to the Standing Fire Advisory Council, SFAC, and this was in the year 1980, and they are the ones which gave recommendations for constitution of fire acts by different states and all, and they also gave guidelines on what kind of fire services needs to be provided, what equipments needs to be provided, and so on. Now, based on the recommendations of the Fire Advisory Council, several states came up with their own fire acts, as per the recommendations, of course, but many states didn't come up as well. So, Fire Act currently, the Disaster Management Act 2005 and eventually the National Policy on Disaster Management stresses on or provides a model Fire Act which could be also adopted in different states. Now, fire services in India, as per the 12th schedule, it's a mandatory obligation or responsibility of the states, union territories and the ULBs. So, it has to be taken up, and so in most cases either the municipal corporation takes up these services or the state home department is in charge of the fire services for that particular state. So, several states in several cities have taken, ULBs in the cities have taken up this responsibility, but in many cases or in small towns and all, the home department is the one responsible for providing these particular services. In addition, airport authorities of India, different large industries, Central Industrial Security Force and some armed forces, some units of armed forces also owns fire services, and usually in case of an event, they also aid in the local fire services as well. So, in case of major disasters and all, these agencies also come forward to provide their expertise as well as their manpower and equipment. Now, as per the Standing Fire Advisory Committee norms for fire stations, the fire stations needs to be set up with considering a response time of 3 to 5 minutes in urban areas and 20 minutes in rural areas. So, we will discuss about response time. Primarily what it means is, in case an event is recorded or reported, the fire tender should take around 3 to 5 minutes to reach that particular event, right? So, that's the response time. So, how many fire stations you require, how many fire tenders you require, all this depends on the density or the way the land use is there in that particular urban area and the street network for that particular urban area. So, considering the scale of population that has to be served, the norms given is something around 1 fire engine for every 50,000 people and 1 fire station for every 10 square kilometer of urban area, and for rural areas it could be considered as 50 square kilometers. So, in 10 square kilometers, if 1 lakh people stay, in that case we will have 2 fire engines and 1 fire station. The number of minimum standard equipment that are needed and manpower required for its operation, that means how the fire station should be organized, what equipment should be there, these are also specified in this particular fire advisory norms that are given by the fire advisory norms. Now, this particular advisory committee also recognized that our country is lacking in fire services to a huge extent. For example, we have the deficiencies to the extent of 97% in regards to fire stations. In regards to firefighting and rescue vehicles, the deficiency is around 80%. In regards to fire personnel, the deficiency is around 96%. So, it's a huge deficiency that needs to be addressed. And that's why there has been many cases of fire in recent years, and in many cases we have found out that the complexity of the events are so difficult. For example, when there was an event recently in Kolkata regarding one hospital fire, the patients died because they were not able to be evacuated. Then there are other cases where chemical fires are there. How to fight those kind of fires? In cases where maybe a X-ray or a radioactive machine gets compromised by a fire, how to deal with those kind of emergencies? So, there are a lot of technical concerns also which has to be addressed. So, particularly firefighting capabilities of buildings. Each new building that are coming up should have its own firefighting capability, as well as not only internal sprinkler networks but also peripheral fire this hydrants and so on. So, but in many cases buildings don't have that. In addition to that, they should have adequate escape routes and equipment such as escape chutes, which are not there, and buildings should also, or complexes should engage a fire officer who will conduct regular fire drills so that the occupants know what to do when an event of a fire. So, all these things are missing in many cases, and this requires proper inspection, and right now it's mandated that every building needs to have fire clearances to be given the final completion certificate, and this inspection and fire clearances are usually carried on by the fire services department. And there has to be strict penalties for violation of rules, otherwise people will not follow, or people will somehow go around this or bend this particular rules. Now, the other aspects of firefighting is of course the right of way of fire tenders. As you can know that in India we have very limited right of way, and many cases large fire tenders have difficulty negotiating the traffic and all. So, maybe we can look into those plans needs to be formulated, and also proper parking provisions in the areas where firefighting will happen. So, suppose in critical areas there has to be parking provisions so that fire tenders can be parked there and then they can fight fire. Then the other aspect is water scarcity. Many of our urban areas are very dense, it doesn't have water bodies nearby. So, we have to make provision for natural sources, rainwater harvesting if required. Detachable water tenders could be also added. We can have added this water storage. We can also have water storage tanks at strategic locations, and also fire hydrants could be laid out, and certain new technologies such as mist spray and all these things could be considered for fighting fire, or make sure that we can use less water to cover more area, such as this technology, or to provide make provisions for storage of water at different locations. Then finally, inadequate training of community members to fight fire hazards. So, we don't have any proper training of community members and all, so that in case of fire how they can help the fighting it and so on. So, this kind of trainings could be conducted as well. So, these are some of the aspects which needs to be looked at, or these are the deficiencies which needs to be taken care of in our country. Now, this chart shows the different fire station requirements as listed in the National Disaster Management Guidelines, and so you can see that when we are creating a fire station or we are reserving area for fire station in an urban area, so these are the different things that is required: appliance room, office space, watch rooms, store rooms, work rooms, rest rooms, drill tower, petrol store, hoe washing, smoke chamber, hydrants, record room, and so on. So, these standards are given. As you can see that where there are for single unit fire station, tender fire station, these are the values which are given over here. For multiple units, the floor size is multiplied, and actually we have got different set of requirements for larger fire stations as well. So these are standards which could be followed to determine for a particular area, for a particular population group, how many fire tenders would be required, and for that many number of fire tenders and that many number of, and we can determine what would be the location of the fire station and what should be the size of the fire station. So size of the fire station can be determined using this particular chart. So how many fire tender requirement is there? So these are water tenders or vehicles which, which these water tanks which are actually used for fighting fire. So usually for 50,000 people we should have 1, for 1 lakh people we should have 2, but for 3 lakh people we can have 6, and for additional 1 lakh we should keep on adding 1 fire tender. So this is more or less the standards given in the National Disaster Management Guidelines. Now, as per your DPFI, it has given some additional considerations for urban planners how they should provide this fire stations and so on. So the station location should be such that the fire tenders can reach disaster site at 3 to 5 minutes. Same standard as given in that committee guidelines. Fire station on corner plots preferably, so that movement of the vehicles, parking of the vehicles are easier. And it should be definitely on the main roads with at least 2 entries, so that the roads is easily accessible from other areas. Underground pipelines for fire hydrants at the periphery of new developments. All new developments should have these fire hydrants at the periphery, so that fire tenders can put in their hoses over there and use that stored water for fighting fires. Underground, overground fighting measures such as water lines, hydrants where fire station is not advisable or not available or not possible. So there are many dense areas, but at least we should have fire hydrants so that fire tenders can utilize those. Then approval for fire departments while laying the services for an area. So because there are multiple fire hydrants and all services that has to be laid out, it should while laying it we can also have to take permission from the fire department as well. Now coming to emergency fire service design, there are different things that we need to first understand. For example, first we have to understand about the fire demand zone. Now how do I categorize different areas and say this is one zone and then the other zone is different? So it should have relatively homogeneous land use. So that means the zone should roughly be uniform. It's better to not have a industrial area with a residential area. Why? Because the hazards are different, the risks are different. So we should have different provisions for fighting fires in an industrial area compared to a residential area. So that's why we should make zones which are relatively homogeneous. So a zone can be a single complex of buildings, or it could be a factory producing or using hazardous material, or it could be a church or a hospital, or an area of relatively homogeneous structures, maybe residential area. Now how do I determine the amount of requirement for that zone, or how do I determine the distance from that zone? For that, we have to determine demand for fire service within a zone. We determine a single point, that is a focal point. That means I have got a large area. We break it into different zones, and there could be a focal point for each zone. Now the focal point could be the centroid of the zone, or it could be the major, the risk or structure which is susceptible to fire. That could be also the focus of that zone or the focal point of that zone. So whenever we measure the distance of or the time taken for a fire tender to reach that particular zone, we will measure it from the location of the fire station to this particular focal point. Okay. So focal point represents principal hazard for that zone or the centroid of the zone, where all centroid of the zone could be considered by weighing all the hazards. Like for example, this is a zone, we have got one industry over here, residential area here, each has got different levels of risk or hazard, and then based on that risk we can give weightages, we can multiply that and determine which is the approximate centroid for that zone. So it may not be the geometric centroid, but it could be centroid as per its distance from the different levels of risk at the different parts of that zone. So it's a weighted point or location inside that particular zone. So basically it's a representative point in that zone which is considered as the which could be used for further calculations of distance and other things. Then jurisdiction is the bounded geographic area, may be separated. Now this we can say this is the bounded geographic area. It could be based on administrative boundaries, but this can also be separated by a mountain range. There could be a river in between. There could be a railroad track. So all these things needs to be considered when we consider the jurisdiction, and we can again divide it into that, okay, one fire station will serve this part, other fire station will serve this part, right? Now, along with this area, we should also have detailed information on the street network of that area, and the focal point is basically a node in that street network. So that is how, if we do, earlier we have learnt about this network analysis and all. Well, we are learning about solid waste management and solid waste, carrying of solid waste from one part of the city to another. So here also a node, this particular zone is basically a node in the network when we calculate the network distances for travel time and so on. The next concept is that of critical response time. That is the time taken by the first responding fire engine to arrive at the site of fire after receiving the complaint. So this is the fast fire engine. So this is the one which is the fire engine which is dedicated for this particular zone, how much time it will take to arrive. But of course, other fire engines can join in from the surrounding zones, but they will reach a little bit later maybe. So that's not a problem. So the first responding fire engine's response time is taken as the critical response time. Then size of the fire demand zone could be determined as per the critical response time. So if critical response time is 90 seconds, then fire demand zone could be designed in such a way so that it is lesser than 90 minutes of driving time. So suppose I have a city, I have to design this, this radius of this fire demand zone in such a way so that of any fire that breaks out in this particular zone, or maybe at the focal point of or the main hazardous industry of that zone, in that case the time taken to reach is only 90 seconds. So accordingly I have to determine that around one station, what is the extent this vehicle can travel to reach the different points. So that becomes the fire zone for that particular station. Now next comes the classification of the different risk. Different areas have got different risk. For example, flammable and explosive risk factor is there for gas stations, LPG stations and factories. For general hospitals and schools, these people are vulnerable. So that means they have to be evacuated. There need to be stretchers to carry these people. So that kind of provisions has to be done. Shopping malls, supermarkets, entertainment venues, subways, train stations are crowded. So you need to manage the crowd. So you require other sorts of manpower. Government offices, scenic spots, scientific premises, libraries, science, technology museums, archives, galleries. These are key areas which need to be protected. Residential areas are general fire protection areas. Emergency shelters are emergency protection areas. So accordingly, we can classify these areas as per different kinds of risk, and based on that, we can determine what sort of services or equipments we should carry, or how important is that risk. All these things can be determined from this. In addition, we can map other hazards as well, such as geological hazards, maybe subsidence is there, maybe other issues are there, meteorological hazards, biological hazards, human caused certain kinds of event, intentional like terrorist activity and all these things are intentional hazards, technological hazards based on certain failures of technology and all. So all these different kinds of hazards could be also there in an area, so that also needs to be considered. Along with that, we determine the hazard, risk and all. For that, we can determine that, okay, how we can categorize the different zones. Once the zones are segregated, each zone can be given a focal point. We can determine the response time to that particular zone, and based on that, we can determine the number of stations. But along with that, we also need to develop communication, early warning and operational procedures for fire services. That means if I don't have standard operating procedures during an event which doesn't fall into the obvious category, then how do I deal with that? So to prevent confusion during emergency periods, this also has to be written or also has to be specified. Then finally, there has to be a disaster management plan. That is, in case of a disaster, how do I deal with that? So to determine what sort of hazards, then the time of those particular hazards. So we need to create certain databases. So fire and rescue calls and their timings for the last 5 years are usually recorded. For example, total number of fire and rescue calls coming from a particular area, such as number of fire calls, number of rescue calls, number of gas leaks, building collapse, hazardous material call, animal rescue calls, and other calls. And similarly, we record data on lives lost, lives saved, numbers of injured, property saved, property lost in financial terms. Based on all these records, we can determine which zones are more hazardous, what kind of hazard it is, and accordingly we can designate separate zones in an area. Now, and then also we record the timings at different calls received from 7 hours in the morning to evening, and from evening to again in the night, throughout night to 7 hours. So we can record the calls which are coming on at what time of the day. This will help us to understand or predict the requirement for staff, equipment at different times of the day, at different seasons even. So that actually helps us to do trend analysis to determine what kind of manpower we should have at different points of time and what sort of preparedness we should have at different points of time. Then there are different kinds of fire response units. Usually there is a fire suppression unit. This is a fire tender or a pumper, along with manpower, of course. Primary function is to control and extinguish fire. Then there is a fire rescue unit, which is basically a ladder or a truck, with primary function is to rescue person from sites above the first floor level. So people willing to jump out of a window, or maybe somebody got stuck somewhere. So all these things are important. So this is the fire rescue unit. And then there are special support units which have special equipment or manpower to support either the fire suppression unit or the fire rescue unit. So in India, usually we have multi-hazard response units. That means units can also respond to multiple kinds of hazards. So we have got different kinds of personnel inside each unit that could be utilized to respond to different problems. So the response time, now we have to determine that how do I do location allocation of fire services? How do I distribute the different fire stations in an area? So the response time is the primary factor, of course, that we have learned. So it depends on the area where incident has occurred and the pattern of fire incidences. So that means in an area, if a fire breaks out very often, that means at one point of time there could be multiple fires. So based on the incidence patterns that from recorded data, we can determine that, and also the area, how dense it is, what sort of people live there. All these things plays a role in determining what sort of response I should provide and in what time I will be able to provide it. Then the nearest station location from that particular area and the road network characteristics and specifically travel speed that is possible in that area during that point of time. So this overall determines that at what distance we can locate, at what density we can locate this fire service stations or fire stations in an urban area. Now, site selection and layout planning for fire stations is based on available land, of course. These are primarily government land. Then optimal site selection by minimizing the total travel time of all engines traveling to the fire. It could be just for, we can determine one dedicated fire station for one area or one fire tender for one area, or we can have that, okay, we can consider that multiple engines will travel to that area from surrounding zones as well. So we minimize the travel time of all engines together. So this is basically a location allocation problem. And in GIS, we can solve this very easily using some tools. And here we can determine the location of the fire station as per the distribution of events and so on, or fire events or so on. So in case of multiple engines, both the first and the reinforcement engines, both their times are considered, and accordingly we determine which would be the suitable location for the fire engines. For example, the way we go about is, I have the city, we divide it into different zones. Now I locate the fire stations based on available spaces and all these things. So this becomes one option, and some locations could be skewed. Then we can determine the, okay, in case we then put a distribution of fire events and see what is the minimum time in which this could be addressed and for different fire events. And based on that, we can minimize the overall travel time for that area and determine which should be the best possible scenario for locating with that fire stations in that area. So, the other considerations are not only available land, but how much of it. So, if there is adequate area or not. So, there should be space for offices, watchrooms, stores, workrooms, restrooms, drill tower, petrol stores, hoe washing, smoke chambers, drill ground and other facilities. So, all this should be there. And other parameters such as distance from other services, distance from population centers, relevant land uses, proximity to health centers, storage centers for equipment, crisis management centers, proper road network, all these things also plays a role in the selection of location for a fire station. And people use different techniques for determining. So, it's basically a two-stage procedure. The first stage is to consider all these parameters and determine how important these parameters are in the decision making process. So, usually people use fuzzy AHP processes. It could be an analytical hierarchy process or fuzzy analytical hierarchy process. And then geographical information system is usually determined to determine the travel time or response time to different fire events and all. And based on that, these two data, that is the importance of that location as well as response time, we can take a call on which is the best possible scenario for setting up fire station, or which possible locations are best set for setting up fire stations in an urban area. So, the allocation models could be of different types. One could be a time constraint model, where in the conventional approach, the idea is a station has to be located within a given distance or time of each focal point. So, we have got different focal points in an urban area, more hazardous areas and so on. So, the fire stations has to be located in such a way so that they are within a travel time, given distance or time from that particular focal point. So, this is a constraint based approach. So, there is a constraint of travel time. The penalty function, so we can use utility functions here as well. So, a penalty function is introduced where the delay in critical response time for fire demand zone is based on the allocation is determined. Suppose we have a certain scenario of allocating fire stations in an urban area. So, if I do this sort of allocation, what is the overall delay that is happening? So, we determine the delay in critical response time compared to the standard, and then we change the locations, and then for another scenario 2, we create locations in another point, and then we again determine the delay. Wherever it is least, we will adopt that as the best possible option. But initial locations are selected based on other factors, weightages and so on. Now, weighted time model is where we minimize the disutility associated with selection of stations for a given number of fire units, and here the disutility is determined by, it's a product of importance weight of the fire demand zone and the response time for the fire unit. So, it's not only just based on the response time, but also based on the importance of the fire zone. So, if an area is important, so if I am delayed to reach there, then there is more chance of damage. So, that is why importance of that area is multiplied with the response time, and overall we determine the utility of locating these stations and then determine which sort of option is the best option, and then we choose that option. Now, multiple dispatch model is a modification of the basic model, where in basic model we only consider one demand zone can be served by one fire unit, whereas in multiple dispatch model we can assume one demand zone could be served by multiple fire units from other areas. So, in this case, the objective function is to minimize the total travel time of the total units required to suppress fire in the zone. Now, there is one variant of this weighted time model, which is the balanced workload model. So, here where in case of weighted model, whenever an alarm is there, that is a event has happened. So, each alarm is serviced by the closest unit location. So, that means the closest fire station will respond to that. But in case of balanced workload model, the idea is workload of fire unit is directly proportional to the importance factor of the fire demand zone, and each unit is assigned the same total workload. So, that means every unit's workload should be similar. So that means one unit can reach a certain area, another unit can reach a certain area, but the location of the unit should be such that overall workload for this particular unit is same, because the hazard and all these things are different for this area. So overall workload needs to be balanced for all the different units. So this is a much more complicated way of doing this thing. So this is the most basic way. This is where a little bit complication comes in, because you have to understand the importance of each zone, and this is further complicated because we are considering multiple fire units will respond to one. We can do that over here as well, but over here definitely we have to understand that each unit has got different workload. We have to balance not only the response times, the importance, as well as how much work each unit is doing, and that has to be prioritized. So this is a case study from Tehran. The selection of location is done in 3 stages. So the first stage is pre-selection of certain plots or areas where I can set up the station. This could be done using GIS tools. So over here the considerations are land use compatibility, quality of the building, size of plot, building age, level of occupancy, number of floors, building density, building materials. All these things are considered to do some pre-selection of plots where we can set up the fire station. So, and then based on some GIS tools and all, this like union, intersection, these are standard GIS tools of, like when you overlap different layers, you can take out certain portions of it, right? Common shared areas and so on. So using this kind of standard GIS tools, we can determine based on which are the available areas where we can set up fire stations. So this is the first step. The second step is where using an AHP, we determine the importance of those particular areas. So here population density, accessibility, nearness to high risk, plot size, all these things are considered for defining the AHP model of site selection for fire station and selecting approximate variables. So that means we determine which variable is more important compared to the other using pairwise comparison, and we give weightage to different aspects, and overall this helps us to determine the second layer of importance for the different locations, you can say, right? So here the third stage is, once we have determined the importance, we now need to determine the distance of travel or the response time. So third stage of analysis involves network analysis. Using network analysis in GIS, we can determine from any point or the location of the station what is the time to reach all the other points. So that we can determine, and we can add this all up to determine a figure for total amount of time taken for response. So multiplying with the importance of that particular factor and the response time, combining all these factors, the location of optimum sites for fire stations are determined in this particular study. So these are some of the references that you can use. To conclude, efficient, well-planned and well-equipped fire services are essential to respond to fire events, and significant deficiencies in regards to fire services in India needs to be addressed through adequate funding and technological interventions. Thank you.